Warriors in Their Own Words, is brought to you by the Honor Project, committed to putting the heroes of our nation on record. This presentation is dedicated to the brave men and women of the United States Armed Forces. General Frank Pete Everest was a record-setting U.S. Air Force test pilot. As a fighter pilot in World War II, he flew over 150 combat missions. He then went on to lead the Air Force Flight Test Program, flying with other legendary pilots like Chuck Yeager and George Welch. From 1950 to 1956, he flew an average of 8 newly designed aircraft a month, setting records like taking the Bell X-1 to an altitude of 73,000 feet and the X-2 to a speed of over 1,900 miles per hour, making him the fastest man alive. We interviewed Pete Everest, and he told us great stories of those pioneering days of experimental aircraft and daring test pilots.
When I was a youngster, I used to watch airplanes over my home in West Virginia flying, and one of the characters that used to do a lot of flying was Skyline Scotty. And I'd lay in my backyard and watch him do acrobatics, and that's what I want to do with my life, is to fly. So I did all my education towards that goal, and then I was attending West Virginia University, and when the war broke out, and I had gotten my private pilot license through the CPT program, and so I entered the Air Force and was trained as an aviation cadet, graduated, got my wings and my commission in 1942, and became a fighter pilot. And I checked out in P-40s in Baltimore, and then got our squadrons together and was sent over to Africa to fight the Rommel and his ground forces. And I flew 100 missions there in Africa and Italy. Came back to the States, was stationed in Florida as an instructor pilot for other pilots who were coming into the P-40 program. And got fed up with that and volunteered for combat and went to China. In China, I shot up a couple airplanes on the ground, but then I got shot down.
Can you tell us about that? How did that happen?
Well, very foolishly. I shouldn't admit to this, but I will. I was squadron commander, and in the morning I'd gone out with 3 other guys, flight of 4, and our group commander had signed the 4 squadron commanders different sectors in China to keep covered, and we had to keep the bridges knocked out and airplanes off the airfields in your particular sector. And my sector was Nanking and up the Yangtze River. And I'd flown up there and found a huge truck farm, and we'd shot up a bunch of trucks. And then we were coming home, and I had 2 airplanes on one side of the Yangtze River and 2 airplanes on the other side, and we were looking for shipping. And what the Japs did, they would dig out replacements alongside the riverbank and camouflage these boats. And when we spot one, well, I'd make a note on the map, thinking intensely to come back and finish up the truck farm, and then come down the river and knock off some boats. So that afternoon, I brought the whole squadron, 12 airplanes up. We finished up the truck farm, shot up all the trucks, and then I took my flight down the river and where we had spotted the boat. And we shot up a couple boats, and I found another one that I had located. And so I had my flight, and I put them in trail formation to start making passes on this boat. So I made the first pass, and usually you're looking to pop the boilers, and then you see the steam come out. Well, I made this pass, and I didn't pop the boilers, and that made me angry, so I racked my airplane around and slowed down and came in on that ship and started rudder walking to spray it with our 50 calibers. I still didn't get any steam. Apparently the boilers were down, but a machine gun nest got me real good. It hit my aftercooler, which permitted steam to come back and started to scald me. And so I pulled up and got on the other side of the river and bailed out. So I became prisoner of war. And unfortunately, you have a pointed talkie, which is a little book. It has Chinese characters and English, so you can talk to the Chinese people. So we were able to offer them $20,000 in gold if they get us back to friendly territory. So I'm going through this with the Chinese people, and they said, yeah, okay. So it was the Chinese puppet troops that were working for the Japanese that picked me up. So they said, we'll get you back. So that night they shaved me, and they gave me a little Chinese putty uniform and one of those Chinese hats. The next morning we got on a horse and we headed north. And so after a few miles on this horse, I said, boy, we're going the wrong direction. I said, I want to go south, not north. North is a bad place. He said, no, we got troops here. We got to go north and get up around the troops back down. Okay. So I'm on this horse for 12 hours. And I hadn't ridden a horse for a good many years, and boy, was I sore. But we ended up in Nanking that night, and they said, just be careful, don't say anything, we'll get you out of here. The next morning I woke up and there was about a 6-foot Japanese general standing over me with his sword punching me. Get up, you're a prisoner of war. So that lasted for about the last 3 months of the war. When I heard that Japan had capitulated, surrendered, the commandant of the camp was a little colonel. He wasn't as tall as I was, and I'm small. And he wore a big long sword he kept tripping over. He had big handlebar mustaches. So when we heard the rumor that Jap had surrendered, I demanded an audience with the camp commandant. And they said, okay. So they had an interpreter in there. So I went in and saluted him, And he said, what do you want? Through the interpreter. And I said, I understand that Japan has surrendered. And if so, I demand that you turn this camp over to me. And the poor little guy, his eyes got big. And he couldn't imagine I was a captain, but I'd been promoted, and I didn't know I'd been promoted. He couldn't imagine some guy doing it. So he would jabber with all these other officers, and finally he says, no, I can't do that. I said, I'm not asking you to do it. I said, I demand that you do it. He said, no, I'm not going to permit that. I said, why? He said, well, I have so many fanatical guards. He said, were I to turn the camp over to you, they would run amok and kill half the people, if not all of them, in the camp. And he says, so we're just going to continue as is until you're contacted.
You were shot down in a P-51, and the P-51 was notoriously vulnerable at low level. You guys knew about this, the oil cooler and the radiator, but there was nothing you couldn't vary your tactics? Or?
Well, like I said, I very foolishly racked my airplane around and slowed it down because I didn't see any enemy fire on the first pass, and I was rudder walking in, so I got stupidly too slow, and I should have backed off and made a high-speed run in there. But yes, the Mustang was more vulnerable than perhaps the other airplanes, the P-40, and we didn't have jugs, P-47s, which was a real tough bird to shoot down. So that was my own mistake.
So the tactic wasn't a P-51 on doing air-to-ground work. You come in fast, make one pass, and get the hell out?
Get out, you should do that. And I foolishly did not do that. I had a new guy with me. He had just been assigned, so I was showing him how to do it. I showed him how to do it, how not to do it.
Okay, so you come back to the States. Now, a lot of guys were getting out of the military at this time, but you didn't. Could you tell us about that?
Yes, like I mentioned before, I love to fly. And so I wanted to stay in the Air Force. And I like to fly different airplanes. And during the time that I had gotten my wings until I was shot down, which would be about 2.5 years, every time I had a chance, I'd fly a different airplane. And when I was stationed in Florida, between tours, I flew the A-20, the A-24, A-25, B-25. So I'd racked up different airplanes during that tour. And then I went to China. When I came back, I was assigned to a redistribution center, which was at that time down somewhere Alabama. Presumably, the people who were reassigning the various pilots who wanted to stay in looked at their background and say, well, this guy, he's got a civil engineer degree, we'll make him a civil engineer in the base. Or this guy has a law degree, so we'll make him a lawyer, and so on and so on. Because I had flown these several different type airplanes, presumably they assumed I might make a good test pilot. So I was assigned to right field under the Flight Test Division, who was then commanded by Colonel Al Boyd. There were 3 of us that were assigned to the Flight Test Division, and all 3 of us were fighter pilots, so we were assigned to the fighter section. But we reported to Colonel Boyd, and he, in front of his desk, we stood at rigid attention, and he looked up and he said, I didn't ask you guys, I don't want you guys. You're on 3-month probation, and after that, you'll probably be out. So we saluted and turned around and went out. Of the 3, I was the only one that was kept on. The other 2 both got out of service. Why I was kept on was never explained, but I was eager to fly, and I flew a lot and checked out in a bunch more different type airplane. I think Colonel Boyd was watching this on the monthly reports, flying time reports, because eventually 2 other outfits had requested me be assigned to them, and I had turned down one and he had turned down the other without telling me about it. So after 3 months probation, I was in, and things went very well after that.
What was the early community of test pilots? This was still the Army Air Corps at the time, right?
Yeah.
I mean, was there a formal training program test pilots went through?
Yes. It was no longer Army Air Corps. They had become U.S. Air Forces, but it wasn't separated from the Army yet. But they had formed a test pilot school. But you went to 2 courses. They have one that's called a performance course, and that's how you learn how to check out a new airplane on performance characteristics. That will be speed, altitude, and cruise control, how far it goes, in other words. And it's very tenacious. You try to fly your tests within 1 mile an hour on airspeed, and you try to fly it within 50 feet on assigned altitude. So you learn its range, you learn its speed, and you learn its maneuvering characteristics, but that mostly is covered later in what they call stability course, and that's when you learn how it maneuvers, learn its dynamic stability in both directional, lateral, pitch, and roll. And it's probably the best course because it really determines the good aspects of an airplane, particularly in fighters, on maneuverability. Of course, the bombers and the cargos and the helicopters have different test programs. They're mostly on the bombers with range, the stability on dropping weapons, and on the cargo on range and the load carrying capability, and on helicopters on stability and how well they perform. And you do other things too in the cockpit, the instrumentation layout, the controls. However, during the initial years that we were at Wright Field, I was at Wright Field, we developed what we call a HIAD, which is the Handbook Instruction for Aircraft Developers. And it more or less standardized the layout of a cockpit. the hand controls, the throttle controls, the flap controls, where you put the instrumentation on the attitude indicator, airspeed indicator, altitude indicator, engine instruments, oil pressure instruments. So that was more or less became standard, and it became easier later on to go from one airplane to another, because you knew if it was a fighter, they had a stick here, throttles here, landing gear here, flaps here, and so you could transition fairly easily. The most important part was handling characteristics, stability, and performance. In fighters, you got to have a pretty stable airplane because you're tracking to try to shoot down an enemy airplane, another airplane. Also, if it's an air-to-ground bird, you have to be stable on dropping bombs or shooting rockets. So you go through these characteristics, and you determine how maneuverable the airplane is, and then you come up with recommendations. For an example, in the first F-84s, they were straight wing. Once they got into service, though, we started losing a bunch of them, and we were pulling the wings off, and we weren't too sure why. I ran the stability test on the F-84, and we found out that when you're maneuvering and you're pulling back on the stick, you had certain, like you wanted to have 8 pounds per G. 1 G, 8 pounds, 2 G, 16 pounds, and so on up. So you're pulling 7 G, which is a max the airplanes were designed for, 7.33 G, that you'd be 7, 8, or 56 pounds. But on the F-84, when you got about to 4 or 5 Gs, the control forces reversed, and you had to push forward to keep from over-G'ing the airplane. And we found this out through this test, and so we redesigned the flight control system. We put a bob weight on the stick, so when you're pulling G's, the bob weight would increase the stick forces. So we solved that problem in that manner. So it's the stability phase of the testing program resolved the handling characteristic, the problems of a handling characteristic of the airplanes. Of course, these days they got simulation computers, and they can program these things into the simulators and determine if you're going to have problems before you flight test them. For example, the F-16 without computers to control the 3 stability parameters could not fly. It was a very unstable airplane. So it's testing per se today, because it's computers and simulation, has become very sophisticated and less demanding on test pilots per se.
When you were at Wright Field at that time, is that where you flew your first jet?
Yes.
Could you tell us what that airplane was and what that was like, please?
Yeah. The first jet was the old P-59. They only produced, I think, about 60 of them because its performance was very poor. But of course, I was the new guy in the outfit, and so they weren't letting me fly the P-80s that they had. And that was the latest jet that we had, and a very good airplane for those days. So they had an old P-59 sitting around down there, and I said, well, let me check out on that. And they went, okay, so that's my first jet, you know, and I'm excited about getting in this P-59. So I jumped in it and took off, and leveled out about 2,000 or 3,000 feet to get max speed. Both throttles were full forward, you know, and I'm sitting there and waiting. I got to about 330 miles an hour, and things wasn't going any faster, and I kept checking to make sure my gear was up, my flaps were up. And all of a sudden, I see an airplane out to the right, and it's a Mustang inverted with Yeager in there, thumbing his nose at me as it goes by. So that was a disappointment flying the P-59. But later, not too much later, I got to check out in the P-80, and that was an exciting event because performance was outstanding as compared to the P-59.
What's it like to transition from a prop to a jet? I understand it's much quieter in the cockpit, but what about the control forces?
It is much quieter. There's less, almost nil on vibration, and it's very peaceful. The control forces in the P-80 were boosted controls, hydraulically boosted control, so there wasn't any problem there. On takeoff, you'll notice mostly that you have a little over control laterally, and you'll notice the guys when they're first checking out, their wings would walk a little bit. But after you get used to that, there's hardly any problem.
When did you first meet the F-86? Can you describe that?
Well, that was while I was still at Wright Field. They had the F-86 that they brought in. It was a low performer because it had a J-35 engine. And we would take it to various air shows when it was in commission. I had one air show in Miami, but it had slats on it that were mechanically locked, along with other deficiencies. And when I went to Miami to put on there, so usually you did some higher rates of roll and you did some high maneuvering, but I couldn't get my left slat to lock. And if you were to maneuver in a high G load, you're liable to pop that slat completely off of the wing. So it was restricted in those conditions. And later on, we got the F-86A in the Wright Field, and we were testing it, and it was a much better airplane. We put on some pretty good air shows with it.
How did you feel about the F-86?
The F-86 was a great airplane. We had the swept wing F-84, the bent wing, we called it, and then the F-84 straight wing. And you kind of climbed into those airplanes. But with the F-86, like the Mustang, you felt like you put them on instead of climbing into them. They fit you better. They fit you well. So it was enjoyable to fly it. And of course, being a swept wing airplane, it was a high performance, much better than the swept wing F-84F. It's more maneuverable, and you could climb to a faster altitude and dive and had better speed brakes and this sort of thing. The F-84F was designed and built for a ground support airplane. And it was built for 9 Gs, which made it very heavy and not very maneuverable. Although you could get a supersonic in a dive, it wasn't at all for an air-to-air airplane like the 86 was built to be.
But the F-86A, as I understand it, it still had standard elevators on it.
Yes, it had boosted hydraulic flight control systems, and we found in Korea that at high speed it wasn't as maneuverable. So then we determined to put a flying tail, what we called a flying tail, which was tying in the stabilizer and eliminating the elevator, as you know in the old days. And the flying tail made it a great airplane. And we also reconfigured the slats. And the slats became maneuverable slats. At the high Gs, they would come out and increase your lift. So that made it an even better airplane.
In 1951, Pete Everest was transferred to Muroc Air Force Base in the California desert. The primitive airfield would eventually become Edwards Air Force Base, with Everest as the Chief Air Force Test Pilot and head of the Flight Test Operations Division.
Colonel Al Boyd, who was the Director of Flight Test at Wright Field, was assigned to command Muroc Air Force Base and to develop it into the Flight Test Center. Obviously, at Muroc, the weather's better. You don't have low ceilings, no rain or snow to speak of, and it's almost 365 days a year you could do flight testing. A lot of times at Wright Field, you have rain, snow, and you can't endeavor to take off and test because of those poor weather conditions. So when he went to Edwards, he selected various people to accompany him out there, not only as test pilots, but also for administration, supply, maintenance, and what have you. Fortunately, I was had made it, so he had selected me to accompany him along with Yeager and a few other people. That was a interest to me because, of course, I wanted to go out to Everest because I knew that it was going to be the main base for flight testing, whereas Wright Field would be the more mundane type of flight testing and checking new synthetic tires, synthetic oils, different types of wings, magnesium wings, and all-weather testing to check out how they performed under cold weather conditions, and the new types of instrumentation, ground control approaches, GCA, ILS, instrument landing system approaches. That would all be done at Wright Field. And I preferred to do the testing on the newer airplanes, so that's why I wanted and went to Muroc Air Force Base.
So what was Muroc like?
It was in very poor shape. It had been set up as a base for World War II to use as a bombing range and testing range for the crews that were in the bombers and getting ready to go overseas. As a matter of fact, they had a silhouette of a battleship that I had set up out on the lake bed, and they could come in and drop bombs and strafe and rockets, this sort of thing, to check out in the system. The buildings were in old tar paper shacks and in very poor shape, where little or no base housing to speak of. General Boyd later got Wary housing and Capehart housing. And so luckily he thought well enough of me to put me in one of 10 houses up on the hill next to the commanding officers' quarters. And they call it Snob Hill, so I guess I was a snob in those days. Then all the new airplanes started pouring into Edwards, and it became kind of hectic because when I came out, we only had about 9 pilots, and we had a few bomber pilots, a few cargo pilots, a couple of helicopter pilots, and a few fighter pilots. And we were flying the various tests, but most of us flew about everything. Like I was flying the B-50s and B-29s, and some of the bomber guys were flying P-80s on chase missions. And then we had a few of the X-1 series that we were running rocket tests on. And as the years went by, we would get the F-94, A, B, C, the F-86, E, F, H, and D. D was an interceptor model. We have the P-88, which was the forerunner of the F-101. We have the F-100, F-101, F-102, and F-105. And then we, of course, got the B-47B and C-130 cargo airplanes and all kinds of new helicopters. So we became quite busy, and I had to build up the flight test section to accompany these new systems, and I then broke it out into sections: fighter section, cargo section, which included helicopters, and bomber section. And they more or less became specialized in those categories.
Going back to the F-86, when you were going through your course back at Wright Field or later on, were you made aware of the German experiments into swept wing technology? Was that part of your training?
Yes.
What were you told about that?
Well, swept wing obviously permits less drag. You don't have all that garbage out in front of you, alongside of you. And also with a swept wing, it permits the airflow to slide over the wing without forming so much turbulence as you would with a straight wing airplane. The disadvantage is range. Because of the straight wing airplane, the wing loading is lower, and this increases your range because you can go further and carry a heavy payload. And there's a lot of variable engineering results that have to be computed out. Like in a straight-wing airplane, you could not go supersonic because the drag was so high, and you'd lose loss of control when you started to reach about 0.8 Mach number. The turbulence becomes so bad that you couldn't break through the barrier. With a bent-wing airplane, this all smoothed out, and you could take the F-86 and F-84F and 100 series airplanes supersonic in dives, and of course in the 100 series you can go supersonic straight and level. So that became obviously a standard development program to increase the performance, and it later was applied to the bombers and the cargo airplanes also, because it reduced drag.
Now, at the same time, you were also involved in the X programs.
Mm-hmm.
How was there feedback from those programs onto the operational? Were there anything learned from the X1 or X2 series that they applied to the?
Certainly. With the X1, it was at Edwards before we had moved out there. And Yeager was out there TDY, and I went out TDY for the altitude work in the X1. The X1, once it became supersonic, then we knew we could have airplanes that could go supersonic, because many people felt that once you try to get through the sound barrier, that the airplane would disintegrate. And obviously, with Yeager proved that it would not. So that opened up a whole new ball of wax for aircraft designers, knowing that you could safely go supersonic. And then also you would learn that how the airplane responded at the higher altitudes and at the higher speeds for lateral control, pitch control, and direction control. For an example, Yeager and Ridley, the engineer on the X1 supersonic test, had a problem controlling the airplane at the high speed. They had a stabulator that was movable, but it was not tied in with a control stick. And they finally predetermined that they could reset the stabulator and get better performance. And then even then, we learned they had a toggle switch on the control wheel that you could move the stabulator. So that opened up new avenues with the F-86 F, which we put the stabulator on without the elevator to have better control at the high speed and higher altitude. So the X1 was really a fantastic research program that resulted in opening up new areas of engineering relative to high-speed airplanes later on.
Now, you mentioned before that the first time you ever went supersonic in an airplane was an F-86.
Mm-hmm.
Could you explain how that occurred?
Well, that was because I was sent out to North America to pick up an 86 to bring back to Wright Field to do some testing. And so I took off from North American in L.A. and flew to Muroc Air Force Base. And of course, you knew that the airplane was supersonic, so you get up to 35,000, 40,000 feet over Muroc, and you turn it upside down and put it in a dive, and you watch your airspeed indicator, and when it jumped, that you knew you passed compressibility and were supersonic. And then you call the tower and say, "Did you get a supersonic boom?" "Yes, sir." Then you knew you were supersonic.
The test pilots of those early days needed to be fearless. But sometimes their aggressive spirit could lead to disaster.
Could you explain what happened the day that George Welch, the North American pilot, was killed in the F-86?
George Welch was the chief test pilot for North American Aviation. He was quite a guy. He was one of 2 pilots at Pearl Harbor who took off and shot down some Jap Zeros. I've forgotten how many he shot down. But after the war, he got out, and because of his notoriety, North American hired him as a test pilot, and he became a chief test pilot. He was so aggressive, you might say, fearless, and you really don't want to hire people who are fearless. You want to hire people who respect the bad parts of an airplane and what it might do to you, so that your aggressiveness does not overcome your good sense. George Welch had flown the F-100 on its first flight, and it was the first time in the history in any aviation that the airplane went supersonic. And now, of course, the F-100 was the first airplane to be able to go supersonic in level flight. So we took it from there. I did the performance and the stability control on the F-100, but the contractor has certain test points that he has to meet. And one of the most significant ones, and the most dangerous one, is to do a 7.33 G max rolling pullout. That's the ultimate on fighters. And so George had gone up in the morning of this particular day and put the airplane in the dive and had pulled, I think, 7.1 G in a max rolling pullout, but he didn't meet the 7.33. Well, instead of waiting to analyze the data, because the airplane was fully instrumented, instead of waiting, he wanted to go ahead and redo the test that afternoon to get it over with. And they approved it, unfortunately. So he went up and put it in a dive and got to 7.33 Gs at max rolling, ailerons full max, and the airplane came unglued. And George was ejected. It just, but his chute came out, and he landed, and they called us and said we had an emergency, and I was there, and I grabbed an H-21 helicopter to go out and pick him up and take him to the hospital. And he had told the people on the ground that saw him come down in a parachute to be careful that I'm severely injured. But I think by the time I got to him, he probably was already dead, because I think he had ruptured some of his internal aorta arteries and bled to death internally. So that was a tragedy, and he was a great guy, and we wished that he had not been so fearless as to wait to reduce the data, which would have proven that the F-100s that we had in the early production did not have enough vertical stabilizer. And by not having enough vertical stabilizer, you would get into an oscillation and overheat it, and the airplane would come apart. So we redesigned the vertical tail, put more tail, a vertical tail on it, and became a safer airplane.
With the busy fall season just around the corner, you might be looking for wholesome, convenient meals for jam-packed days. Factor, America's #1 ready-to-eat meal kit, can help you fuel up fast with chef-prepared, dietitian-approved, ready-to-eat meals delivered straight to your door. You'll save time, eat well, and stay on track with your healthy lifestyle. Too busy with your end-of-summer goals to cook but want to make sure you're eating well? With Factor, skip the extra trip to the grocery store and the chopping, prepping, and cleaning up too, while still getting the flavor and nutritional quality you need. Factor's fresh, never-frozen meals are ready in just 2 minutes, so all you have to do is heat and enjoy, then get back to crushing your goals. Level up with Gourmet Plus options prepared to perfection by chefs and ready to eat in record time. Treat yourself to upscale meals with premium ingredients like broccolini, leeks, truffle butter, and asparagus. With Factor, you can rest assured you're making a sustainable choice. We offset 100% of our delivery emissions, source 100% renewable electricity for our production sites and offices, and feature sustainably sourced seafood in our meals. This August, get Factor and enjoy eating well without the hassle. Simply choose your meals and enjoy fresh, flavor-packed meals delivered to your door, ready in just 2 minutes, no prep, no mess. Head to factormeals.com/warriors50 and use code warriors50 to get 50% off. That's code warriors50 at factormeals.com/warriors50 to get 50% off.
Now, at this time, you were also in the X program. You had been flying the X-1 at altitude. You took it to the highest it ever got, I understand.
We did that before we transferred to Edwards. Right after Yeager did the supersonic work, I went out there TDY and did the altitude work. And then we came back. The X-1 program was spread out over a good many years, and we had troubles and then go back to the factory for modification or repair. And so you don't say that you're continually doing it. Like I think I only had 13 flights in the X-1 and a couple in the X-1B and then in the X-2 with the rocket airplane. But we had trouble, like I had an engine blow up, one of the rocket engines blew up, one in the X-1, and so it went back to the factory for repair. And then we had the most serious problem was the tanks blowing up, one over Niagara Falls and one over on the ground at Edwards. And we had to go in and redesign the tanks and the seals on the LOX tanks that or transfer the locks to the rocket. So we all had all kinds of problems. The X-1 series airplane that spread out through a good many years. And I had a lot of problems with the X-2, and it was spread out through a good many years before it was completed.
So you were in between, and all this time you were also test flying fighter type aircraft as well. So you were never really segregated. The testing programs are not segregated between fighter aircraft and X aircraft.
No. Just the fighter guys would fly the X airplanes.
Now, you said you had an explosion and you jettisoned the airplane. Now, you were in the bomber at the time, or you?
I was in the cockpit.
You were in the cockpit of
the X-1D getting ready to drop in the belly of the B-50, which is the mother airplane we used to drop the airplane from. We had previously lost the X-1 number 3 on the ground due to an internal explosion. And it had burned up and severely injured Joe Cannon, the chief test pilot for Bell Aircraft, from burns. He was in the cockpit the same way. Luckily, the X-1 number 1, 2, and 3 had side doors that you entered and exit the cockpit, and he was on the ground and got out to the side. If he had been like the X-1 ABCD, you get in from the top, he would have lost his life. So I was in the cockpit of the X-1D getting ready to drop for a power flight. The canopy was on, and I was pressurizing the LOX tanks. What you do, you pressurize LOX to meet with the nitrogen to go back and fire the rockets. And as I opened up the pressurization valve on the LOX tank, we had an explosion in the rear end behind the cockpit. So I got the cockpit canopy off, jumped up in the front of the airplane and to the bomber, the B-50, and I looked back and we could see, you couldn't tell whether it was smoke or whether it was LOX, because LOX obviously boils off. So I turned to Jack Ridley and I said, jettison the airplane, because we had had a severe explosion before and I didn't want to risk the crews of the KB-50, or for that matter, myself. So we jettisoned the airplane in the lake bed. And so we lost that one. But they later determined that it was problem was with the seals, and as the locks would freeze the seals, they would, with an impact, would explode and rupture the tanks, which would cause a disaster, which we had several disasters.
Now, what about the X2? Now the X2 incorporated the swept wing. And that this was a very dangerous program too. I mean, we lost. Could you briefly describe the X2, how it differed from the X1?
Well, the X2 was designed to reach higher Mach numbers, to go up to Mach 3 and be stable so that you won't become uncontrollable like in the straight wing X1 series. It was a new type of design, and to save weight, they had no landing gear. You had a skid, a main skid, and two little outrigger skids and a nose wheel. All the X-birds, the rocket X-birds, half of their weight was in propellants to fire the rockets. So after you used your propellants up, the airplane more or less became a glider, and you glided back in on a lake bed. To reduce weight with the skid, it still had to meet certain criteria. Like in landing, it's supposed to have landed at a landing impact of 8 feet per second, which was more or less very stringent because that was more or less like landing a fighter on a carrier aircraft. And to accomplish this, they had a long strut, which was on this skid. Unfortunately, some of the earlier problems we had with it was that the airplane became laterally unstable on the ground as you were skidding along, and you end up dragging wingtips and ground looping a couple of times because of this problem. So we looked at our data and determined that on all the landings that we had with the X2, they were very gentle. And so I said, well, why don't we reduce the length of that strut? Because we don't need this 8 feet per second landing criteria. Reduce the length of the strut, which will make it more stable during the skid out. So they did, and that solved the problem. But we had widened the skid, which increased the weight. We had added stronger wingtip skids that also increased the weight. So once we determined that it was easy and we could control the airplane on the run out, we reduced the skid and the weight and reduced the wingtip skid, which put us in a real good position then. And we could continue with the program without having to be overly concerned about landing the thing. A couple of times I thought I was going to roll up in a knot. Once you catch a wingtip, you didn't know what was going to happen. It could tumble on you.
I understand that Gene Ziegler was killed in the X2. Gene Ziegler, who was the...
Yeah, Skip Ziegler was the chief test pilot for Bell Aircraft. Real fine guy. And he did the initial test drops for the X2, and then he got killed in the X2 up in Buffalo, and so I took over and did the rest of the testing.
But after you left, the major apt was killed?
Yeah.
How did that happen?
We felt that I could have gone faster. You have to understand that you're only flying for a few minutes before you run out of propellant. So your flight path has to be very precise. And the instruments are lagging all the time, so you really don't know when to start your pushover. Usually start at, like if you say you think at 65,000, you're actually at 70,000. So you have to start pushing over at 60,000 to meet them. We also felt that we weren't scrubbing the tanks out. And we had, like in both the tanks, you had probes, which the fuel went through back to the rocket engine. So if we knocked those probes off, we could probably scrub out the tanks and get another few seconds power flight to increase the speed. So after I've been transferred, they made those modifications. They put Mel Apt in, and he's a good fighter pilot, a good test pilot. And he flew a perfect flight plan and increased the speed over, mine was 1900 and something, which is about 2.9 Mach number, and he went another 100 miles or so, which broke my record. And unfortunately, though, he was inexperienced in the X-series airplane. And when you run out of propellants, you could be fairly far away from Edwards Air Force Base, although it has little or no concern because the airplane is very light and you can glide back easily. We obviously don't know exactly what happened, but the X-2 cockpit was so tight and tiny that you were cramped in there, and it also separated. If you got in trouble, they had 4 explosive bolts that you would blow off the cockpit from the front of the airplane, and it had its own chute, which would let you down to a lower altitude if you were high, and then you jettisoned the canopy and climbed out of the cockpit and used your personal chute to lower yourself gently to the ground. And as I said, we don't know exactly what happened, but I think what happened was because of his inexperience, he got excited about getting back, turning around and getting back to the base and over control. We knew from test that when you blew the cockpit off the front of the airplane, that you'd be subjected to 15 Gs. Well, he was in an inverted spin. So as he was coming down, and if he was going to jettison the cockpit, you'd be subjected to 15 negative Gs. And with your head right on the canopy, practically touching the canopy, when he blew the cockpit off, he, I think, knocked himself out. And he became unconscious because he came down a long way and he was apparently climbing out of the cockpit when he impacted the ground and killed himself. That's all subjective in my line of thinking, and we never will know exactly what happened.
So we'd actually separated that from the air, the nose itself.
Yeah, he'd blown the nose off. And being an inverted spin, he had a negative 15 G. And so I think apparently it was coming to when he was at lower altitude, and got rid of his canopy and was climbing out when he hit the ground. Real tragedy. Yeah.
Now the X-3 had a short span, low aspect ratio wing, but it was underpowered, I understand.
Oh.
I mean, what was your opinion of the X?
The engine that was going to be installed in the X-3 grew in diameter, and it outgrew the X-3, which was a twin-engine airplane. They were going to put 2 of these in there. So they substituted engines with lower thrust, which made it practically unacceptable. When they were flying it, they kept throwing tread off the tires because it took about 240 or 50 miles an hour to lift off the leg bed. So what they ended up doing was taking the tread off, and you took off and landed with just bare tires, so to speak. Its wing loading was such that it was so high that you couldn't maneuver the airplane. You had to be very delicate with the wheel, or you could over-control it. It also had a high T-tail. You take off, pull the gear up, and then sit there, and then finally climb up to get to altitude. You could get a supersonic and die, but you couldn't get a supersonic in a straight level, which was what it was designed to originally do, to test it at supersonic speeds, handling characteristics and controls. And of course, what little knowledge they gained from it, they applied to the F-104, which also had a high wing-loaded wing. My first flight took off and did some maneuvering, came into land, and normally you come over the runway, a lake bed, and you pitch out and come back, cut the power, put the gear, flaps down, came in land. I came in at 10,000 feet above the lake bed, pitched out, cut my power, put the gear and flaps down, and went to full afterburner to pull out, because it was going down like a rock. And you have to be real careful. It was a very delicate and dangerous airplane to fly, particularly on takeoff when you're taking off on bare tires, so to speak. So although we got some data from it, it wasn't, because of the low thrusting engines, it was not you could say a very good airplane relative to what you got out of it.
Now the X4 was a tailless.
Yes.
What was the purpose of going without a tail?
It was to get data, information on tailless airplanes. Like we had the B-35 and then the B-49, and the X4 was used partly to develop those programs, and probably using some of the data now on the B-2, which is the north of tailless. It was a subsonic airplane, about 0.8 Mach number. Nice little airplane to fly, until you try to go supersonic, then it would uncork on you, and you had to be careful with that. So it was just a simple little tailless airplane.
It's kind of like a shark.
Yeah.
It's a big thing up there. And the X5, the variable incident.
Yeah, it was to research variable sweep angles. It had about the same performance as an F-86. And you would pick out, say, from 20 degrees to 60 degrees, or in time in between, and dial that in and punch the button, and the wings sweep to these various angles of attack. And then you can maneuver and get data on what happens at those different sweep angles that you can have.
Was that the last of the X series that you flew?
Well, we flew the XF-92. I think it probably was the last X. It should have been an X, probably X6 or X7, but they put an XF-92 on it for some reason. It was designed and built and stuck in a wind tunnel with no thought of flying it. But once Consolidated got it in the wind tunnel, it looked like it was fairly good, so they said, well, let's stick an engine in it and go fly it. So they stuck an engine in it, and we flew it. And they put flight control systems in it, but they only had one backup. I mean, there wasn't any backup flight control system. We could get it supersonic in the dive, but they wanted to get it supersonic straight and level because that was a forerunner of the F-102 and 106 series. So they decided to put an afterburner to try to get it straight level, get supersonic straight and level. And so we flew it, but we, the Air Force, didn't think it would go supersonic straight level, but Consolidated did, so they sold the Air Force and buying the 102s. And they had a problem with the 102s on speed-wise, so they had to recamber the wings and Coke bottle the fuselage to get it up to speed. But my last flight in the XF-92, I took off from the lake bed, and I had done some landing data test, I believe, and my master caution warning light came on, which is a big red light up right in front of your eyeball. And I said, oh, and I looked down, and my flight control system hydraulic pressure was passing through 1,500 from 3,000 towards zero. And once you lose your flight control system, because there was no backup, you lost your flight control. Well, I racked it around and landed on a lake bed, and just as I touched down, the flight control was locked. So I recommended they're not flying anymore because we had gotten all the data out of it that we could. But I think they gave it to NASA and they flew some more flights.
That was the first of the Delta Wing
Yes.
airplanes.
Mm-hmm. True Delta. They had the X4, which is tailless, but this was a True Delta.
What about the early ejection seats in those airplanes?
Oh, they're very, I guess you could say they were a little crude. They were limited, obviously, on the altitude that you bailed out and the speed that you bailed out. We had a couple of airplanes we put Martin Baker seats in, the B-57, for example, and later on they became common in other airplanes. I would be reluctant to have used the earlier ones because to clear the tail, they had to increase the power to knock the seat out and over top of the vertical tail. And we had some severe back injuries because of that, compression, vertebrae compressions. Also, our equipment was such that on high-speed bailouts, crash helmets, and oxygen masks, and visors were not adequate to protecting you at high speeds. So this was the same thing with the pressure suits that Yeager and I used on the X airplanes. They were very crude. They could call them partial pressure suits because they weren't fully pressurized. They had capstans that run down your arms and your back and your legs, that when your cockpit pressure failed, these capstans would expand and control your body, and you had a band around your partial pressure mask which also expanded, because above 60,000 your blood would boil, and that obviously did not enhance your longevity. One of my flights in the X-1, a canopy cracked on me and I lost my pressurization, and I became the first man to have a partial pressure suit saved my life. Worked very adequately. But they were torture chambers. You did a lot. You had to go and get fitted, like a tailor-made suit. You wore underwear underneath. But when you would pressurize a suit, you'd split a lot of capillaries because of the tightness of it. And you looked like you'd been in a cat fight when you got down and took off the suit. So it was a true torture chamber until they developed the full pressure suit, which is obviously much nicer and more comfortable. It's more like living in a regular environment now. So those early crude days relative to ejection seats and partial pressure suits were adequate for those days, for that time period, but not adequate for later on. Like now, in our airplanes, F-15, 16, F-4, you can punch out 0-0, which means 0 speed, 0 altitude, and still be safe. You can still punch out at higher altitudes and higher speeds and still be relatively safe. They have rockets on the seats now that don't give you that sudden jolt, but they build up to make sure you clear the vertical tails and that sort of thing. So it's been so much advancement, not only in aircraft design and engine design, but also in personal equipment design with respect to helmets, pressure suits, flying suits. There are now Nomex gloves, which are fire retardant, and you save a lot of lives that way. And it's very fruitful. And I'm kind of glad to have been part of developing these things in the early part of my testimony, because we were helping develop G-suits. We'd go in a centrifuge at right field and they whirl you around and you determine where you blacked out and started to haze out. and then turn on the pressure suit and see how much the pressure suit enhanced you to maneuver at the higher G loadings. And each individual is different. And when they slowed the centrifuge down and bringing you back to stop, you felt like you were tumbling. And it would give you an odd sensation. And that's where I have an advantage over Yeager. He'd get sick when he slowed down and get nauseous. So I tease him about that, amongst other things. And it was an interesting era to have been participating in.
Fighter pilots are known for their aggressiveness and skill, but what is the difference between a test pilot? Do fighter pilots automatically make good test pilots, or what is the difference in your opinion, sir?
Well, I don't think anybody can adequately determine. You obviously have to have the love of flying. You also have to have a desire to experiment and do things. And then you obviously have to have the right stuff, like Yeager had. And although you may end up in dangerous situations, you also must be able to feel that there's nothing that can happen that you can't eventually take care of and control of. Although I lost, I think, 11 pilots during the time when I was out at Edwards for various problems and reasons. You've got to be a volunteer and want to experiment. Whenever I needed new test pilots, they'd come in and I'd interview them. And why do you want to be a test pilot? You like the glamour? And if they just wanted to be a hero, then I wouldn't accept them. I said, are you fearless? Are you afraid to fly? Of course I'm fearless. I'm not afraid to fly. And I would then try to go a little deeper on how fearless they were. Because you don't want a guy that's fearless. You want a guy that wants to have respect for problems that he may encounter and slowly build up to those. And like George Welch, he was fearless. And Ivan Kinslow, who was my protege on the X-2, I think was fearless because he did the altitude work on the X-2. Unfortunately, he was in an F-104 going to make a chase on a contractor bird, and the engine quit, and he kept trying to get it started until it was too late. And he punched out too late. So you have these type of people that you appreciate, that they're fearless and they may be good in combat, but not necessarily make a good test pilot because they may go too far in certain tests.
After his days at Edwards, General Everest assumed commands throughout the world, finally retiring from the Air Force in 1973. During his years of service, he earned numerous decorations and awards, and in 1989, he was enshrined in the National Aviation Hall of Fame. Pete Everest passed away in 2004. He was 84 years old. We hope you've enjoyed this presentation of Warriors in Their Own Words. This program was created and produced by The Honor Project, Heroes of Our Nation on Record, narrated by Bill Ratner. This production is copywritten by Heroes of Our Nation on Record, Incorporated. Any unauthorized broadcast, public performance, or copying is a violation of applicable laws.
Greetings from Evergreen Podcasts. We're rolling out a listener survey, and we want to hear from you. The information in the survey will help us gather statistics and in turn make our shows more appealing to advertisers. I know most people don't like ads, but this is one of the only ways our shows make money and help keep their lights on. We promise it will only take a few minutes, but the impact on our podcasts will be tremendous. As a token of our appreciation, we'll randomly select one lucky participant each month to win an exclusive merchandise package from Evergreen Podcasts. Head to evergreenpodcast.com/listenersurvey to help a show and possibly get some free stuff for doing so. We can't thank you enough for the support. Now back to the show.